Hello and welcome to this section of the MATLAB tutor. Here we're going to learn about the matrix transpose and also how to extract certain part of matrices that can be useful when you're studying linear algebra or when you're using linear algebra or matrix algebra for some problem. So first of all, let's define a matrix and we'll just call this matrix B for now, let's say. And let's just define the matrix just like we always do. 3, -5, 3, 7. Next row, let's make it 5, 5, -7, -8, something like that. And then finally we'll have 0, 1, 2, 3. So here we have a matrix. We have 3 rows and 4 columns like this. Okay. The first thing we want to talk about is the matrix transpose. Right. So the matrix transpose is when you take the matrix that you have and you put this little quotation. It's a single quote. It's a single quote on your keyboard, and there's no space here. You just put the name of the matrix with the quote there, and then what you get back is the transpose of this matrix. So basically you can see what's happened here is the matrix is kind of turned on its side a little bit. So here you have 3, 5, 0. Here you have 3, 5, 0. Here you have -5, 5, 1. Here you have -5, 5, 1. So basically what's happened is we've kind of, if you can think about it, if you can kind of draw a line through this matrix like this, we've kind of reflected this matrix over this line to kind of like fold it over, kind of across this sort of invisible dotted line here, so that everything over here is on the left-hand side of the matrix and so on. So this is very straightforward. You learn about matrix transposes when you deal with linear algebra. So that's very simple. You just do the simple quote, and then it'll go ahead and transpose it for you. Now the second thing I want to talk to you about, let me put the B matrix back up there, is extracting the diagonal of a matrix. All right, so the diagonal of a matrix, DIAG, okay, DIAG. If we pass it matrix B like this, then it's going to do its best to return the diagonal elements. Now this is not a square matrix, so it's doing the best it can. Here's the first element along the diagonal, second element along the diagonal, third element along the diagonal, and it returns that stuff to us. Of course, there's not another row there, so it can't easily return that. But you know, I can go back here and change the definition of B just to kind of make it a little bit instructive. And I'll put 9, 9, 9, 9 or something like this. So this is our new B. And now if we extract the diagonal elements, it's 3, 5, 2, and 9. So this is just pulling off the elements along the diagonal. A lot of times in matrix algebra, you need to pull those diagonal elements out and do something with them. All right. We can also extract portions of this matrix. See, if you look at the square matrix here, there's kind of an upper triangle, which would be these elements over here. And then there's a lower triangle, which are these elements below the diagonal. And MATLAB has functions to extract those because sometimes in matrix calculations you need to pull the upper triangular elements out and the lower triangular elements out as well. So you have TRIU, that means triangle upper. So if we just pass it a matrix, triangle upper, it's going to produce another matrix, but it's basically only going to have the upper triangular elements, including the diagonal that remains. Everything else is going to be sent to zeros. And so now you have these elements that you can use in subsequent calculations or whatever you're trying to do. You also have triangle lower, TRIL. And if you pass it that matrix, you're going to get what you might expect. You have the diagonal, and then you have the elements below the diagonal. All the other elements in the matrix are zeroed out. So these are very simple functions to apply. There's really no gotchas there. So I'm going to close the section off now. Sometimes you need to take the matrix transpose. So let's show you that one more time as I altered the matrix here. If you do B transpose, then you'll get this matrix back. You can kind of envision a line here where we're folding the matrix over. So now this 3 is at the top, then 5, then 0, then 9, and so on. And by the way, if we take our last answer that we just got, which is a matrix, and then we transpose it again, what do you think we're going to get? We're going to get back exactly what we started with. So when you take the transpose and then you transpose it again, it just flips it back exactly how it was before. And that's a good illustration of that. If you want to take the diagonal, you can, so we did diagonal of B before, let's do diagonal of B prime. So in this case, we're going to take the transpose and take the diagonal. Notice that the the diagonal elements along B prime or B transpose are their exact same elements if you take the diagonal across B, because when you take the transpose, it just flips it. The diagonal elements remain in the same place. So when you take the diagonal elements of either one of these things, you get the same answers. And then we talked about triangle upper and triangle lower if you ever have a need to pull those elements out of the matrix as well. So make sure you understand these. These are kind of fundamental things that you learn in a linear algebra class, and they can come in handy.